Hi everyone, these are the Calculus Section 5.4 notes titled The Indefinite Integral and the Net Change Theorem. Thus far, we've been doing definite integrals, not indefinite integrals. The ones we've been doing have had bounds, right? They've had an a and a b, and you've plugged them in and gotten a numerical answer for the net change under a curve. So the only difference between a definite integral and an indefinite integral is that an indefinite integral is quite frankly easier. It doesn't have any bounds. So for example, if I give you the integral 4th root of x to the 7th power dx without bounds, basically all you're going to do is find the antiderivative and then put your plus c and call it a day. So guess what? The indefinite integral is nothing new to us. Okay, in section 5.2, we called it we were calling an indefinite integral the antiderivative, and now you know it's called the indefinite integral. So this is just the antiderivative plus c. And you have to have that, otherwise it's incorrect. So anyway, let's do this problem. No bounds, it's open. So x to the 7/4 power dx. We're going to add 1 to the degree, so I'm going to add 4 over 4 and get x to the, not 11, sorry. I'm going to get x to the 11 over 4 power, divide by 11 over 4, so I'll have 4 over 11 as the coefficient in front, because I'm going to go divided by 11 over 4, and when you divide by a fraction, you can multiply by its reciprocal, plus c, and this is the answer. Okay, that's what an indefinite integral is. All right, one more. What if I have something kind of strange looking? You have to think outside the box. And let's see. What if you have this? You know, cosine theta over sine squared theta is not something we can use the power rule on. It's not a monomial. It's a trig function. And we have to think of the 6 trig functions we know. Is the derivative of one of the 6 trig functions cosine theta over sine squared theta? No, it's not. This is not the derivative of any of them, unless you mess around with it a little bit and think outside the box. So what I'm going to show you is just a trick. Sometimes you do have to think outside the box. So cosine theta over sine squared theta is the same as this. If I can split the sine squared theta into sine theta times sine theta. Then I can group these two together. You know, there's a times 1 up here, and get integral 1 over sine theta. Think about it. 1 over sine theta. That's cosecant theta. What's cosine theta over sine theta? That's cotangent theta. Now, this looks more like the derivative of one of the functions. Actually, the derivative of cosecant theta is negative cosecant theta cotangent theta. So this is missing the little negative sign, right? So our answer is going to be negative cosecant theta. Don't forget the plus c. There it is. Okay. And then, of course, in the same section, they're going to remind you, but don't forget, you also know about definite integrals. They're going to give you problems with bounds. And you have to, you know, these are just review problems here. I'm telling you nothing new. You already know this. And so you would say, okay, how do I find the antiderivative of this? Well, you would split your fraction. You would go, you know, 3 over rad u plus 5u over rad u du. You would, you know, I would get rid of the rads. I would have, this is the same as 3 over u to the half, so 3u to the negative half. U to the first over u to the half simplifies into 5u to the positive half on top. And then I'm ready to do the problem. So I add 1 to the degree and get u to the positive half. What's 3 divided by this new exponent of 1/2? It is 6. Then I'll have u to the, I'm adding 1 to 1/2 and getting 3/2. What's 5 over 3/2? It's 10/3. And then I've got to plug in the bounds because this is not an indefinite. This is a definite integral. When you have bounds, it's definite. When you're missing bounds, it's indefinite. Okay, and so if I plug in a 1, I'll get 6 times 1 plus u to the 3, plug in a 1 here, you get 1 plus 10/3 minus plug in a 0 plus plug in a 0. I'm doing FTC here. And I'm getting 6 plus 10/3, which I believe is 28/3. Okay, so those were just review problems. Okay, so now here's what I want you to do. I want you to interpret. Let's see how much we understand about integrals. Interpret the following statement. So this can be example 4. Here we go. If water from a sink is leaking at a rate of, now when you see rate of, those are buzzwords, R of T gallons per minute. Okay. What is the meaning of integral 0 to 40 of R of T dt? Okay, now pause for a second. In the problem, these are really important problems, you guys, and I gave you some on the homework, so pay attention. Rate of R of T gallons per minute. They just told us something about R of T. The fact that they said R of T is a rate means derivative. R of T is the derivative function. So what's the meaning of integral derivative? We know that it spits out the antiderivative. So if the derivative is a rate, then its antiderivative is not a rate. It's going to be units of measure, not per something. It's just going to be gallons. The rate is gallons per minute. The antiderivative is just going to be gallons. So integral 0 to 40 means total number of gallons leaked from the sink, and it's really important for you to say, over the first 40 minutes. So when 40 minutes have passed, this integral represents the total number of gallons leaked. It's important for you to say the first 40 minutes because it says 0 to 40. Imagine if it said 60 to 100. Yeah, that's 40 minutes, 60 minutes to 100 minutes, but it's not the first 40 minutes. Okay, how about, let me do another one. Let me do it on your sheet of paper. How about this one? Interpret again. So number 5. Interpret. Interpret. If h prime of t is the rate of growth of a person's height. Okay. What does this mean? Integral, 60 plus integral 11, 13, h prime of t dt. Okay, so first of all, let's figure out what's given. It says in the problem that h prime of t is the rate of growth. which means this is the derivative. So when we put an integral sign in front of it, we're looking for the antiderivative. So it will no longer be a rate. It'll just be what the problem is about, which is a person's height. So 11 to 13, so this part of the problem, just the integral itself, just the integral, will be total number of, it was in inches, right? Oh, I didn't say. The rate of growth of a person's height, let me write in inches. My bad, sorry. In inches per year. Oh my gosh, I left out all the important stuff. I'm so sorry. They have to give you this. In inches per year. So this is going to be the total number of inches grown over what? Well, it looks like 2 years. 11 years old to 13 years old, because these are the bounds. But you can't say over 2 years because that could be any age, 20 to 22 years old. You have to say over 2 years starting when the person was 11 years old. So what's this 60 about? 60 is the initial condition. This is how tall the person is when all of this growth starts at 11 years old. So at 11 years old, this person is 60 inches tall. So height of person at 11 years of age. This is how tall the person is, how many inches that person is going to gain over the next 2 years until that person is 13 years old. So together with the 60 inches, and then how much height that person is gaining over the next 2 years, together this expression means literally how tall the person is when they are 13 years old. Okay. Now, let's go on to net change. And this is not going to be anything new to you either. You know net change. And I've talked about this. If I have a curve that looks like this, for example, right? And I tell you that the area of this space is 5, and I tell you that the area of this space is 2, and I tell you that the area of this space is 10, and they're all bounded by the x-axis. And I ask you for total, and this is A and this is B right here, total area from A to B, and I use the word area. I don't use the word net change. The answer to this is 5 plus 2 plus 10, which is 17. However, if I ask you for net change over the interval A to B, it's not 5 plus 2 plus 10. Net change is the same as an integral, and an integral doesn't understand area. So it would actually be 5 minus 2 plus 10, which is 13. So look at the difference between the words and the result. So why am I telling you this again? Well, because now we tie it into the velocity question. And I think at the end of the section 5.1 notes, I told you that distance traveled is going to be the area under the velocity curve. Well, recall. The definition of displacement, if you recall, when we learned it in chapter 3, was S of B minus S of A. This being the end time, if you're given some position function, blah, 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 right? And this is the beginning time. Displacement was this, and I want you to look at something. If I put the velocity function in an integral, right? Velocity over some interval. What's the antiderivative of velocity? Is it not s position? And according to FTC, don't you do s of b minus s of a? Oh my goodness, look at that. So moral of the story, there is yet another word for net change. Okay, there's another word for net change. Yeah, it's integral, but it's also displacement. So when you get a velocity function and they ask you to find the displacement over a certain time interval, you're doing this. This is what you're doing. Okay, a regular integral that we've been doing for a few days now. But when they ask you for distance traveled, oh no. Distance is going to be the total area. This is going to be distance traveled. The displacement is going to be the net change. So what we're going to have to do, okay, because distance traveled, total distance is never negative. You could walk 5 feet to the right, 2 feet to the left, 10 feet to the right, and be displaced by positive 13 feet from where you started. But you have walked a total of 17 feet. That's the difference between distance and displacement. And so how do you do that? I'm going to do one problem with you, and that's going to be the end of the notes. So, example, let me do this in blue. If I tell you velocity is the function t squared minus 2t minus 3, and I'm talking about the interval 2 to 4, let's say. I want us to find the displacement. And let's say this is one of those problems about a particle traveling along an x-axis, with velocity t squared minus 2t minus 3. Find the displacement of the particle over, 2 to 4. So we know that displacement means net change. Regular, old, net change. So that's going to be 2 to 4 of the velocity function, as is. And then so you antiderive, the antiderivative of t squared minus 2t minus 3 is t cubed over 3 minus t squared minus 3t. You evaluate between 2 and 4. I went ahead and did that before class. I FTC'd this whole thing. I plugged in a 4 minus, I plugged in a 2, and I got 2/3 as the displacement. However, when you do the second part of the problem, find the distance, total distance traveled over the same interval, you have to think which piece of the graph, if any, it could be none, but if there's a piece of this graph over the interval 2 to 4 that dips below the x-axis, I have to absolute value that part. Yes, I just said absolute value. That means you have to make sure your answer turns positive. And if you think about this graph, we have a parabola. I went ahead before class and I graphed this parabola. And the piece of the function, this is 2, 3, 4. When x is 2, or this is t and this is v of t. When you plug in a 2, you get -3. 2, -3. When you plug in a 4 into velocity, you get 5. Okay, so 4, 5. And then you do a little bit of factoring here. I'm factoring the function, okay? It's got a 0, sorry, it's minus and plus, at 3. So that piece of the parabola looks like this. Oh my goodness. So if you bound it with x equals 2 and x equals 4, this 2/3 answer that we got for displacement is this area plus this negative area. That's 2/3. Distance traveled, we're going to have to take the piece that's underneath the x-axis and we're going to have to absolute value it, which means when you find total distance traveled, you are going to have two integrals. And how do you split the integral? Well, one of them is going to start at 2, but it's going to end at 3. You know what that is? That's called a resting point. Yep, remember that? It hasn't gone away. It's the zero, one of the zeros of the velocity function. If you forgot what a resting point is, it's where velocity equals 0. And I'm not interested in the -1 because that's not in my problem. So the other integral will start from 3 and go to 4. Now, the piece of the graph that's already above the x-axis, the one that goes from 3 to 4, that can just be velocity as is, because that's already above the x-axis. It can just be the velocity function. But the piece that's underneath the x-axis, that's negative, t squared minus 2t minus 3 dt. This piece, I'm going to do this, I'm going to FTC this. I'm going to antiderive it, evaluate it from 2 to 3. I already know I'm going to get a negative answer. And when I get that negative answer, I'm going to absolute value it. So let's do this one. Antiderive t squared minus 2t minus 3. That's t cubed over 3. And I did it over there already. So you already saw that. From 2 to 3. When you FTC this, plug in 3 minus plug in 2, s of 3 minus s of 2, you actually get -1 2/3. That's what you get. For that area, you get negative 1 2/3 for this space. But because I'm asked for distance, I'm going to absolute value that part. Then I have to do the same thing here. I go t cubed over 3 minus t squared minus 3t. And I do my FTC. So I'm adding these two. I FTC from 3 to 4. And I did that before class. And I got 2 1/3. Positive. Not a shocker since that piece is already above the x-axis. And so the absolute value of -1 2/3 is 1 2/3. Plus 2 1/3 gives me 4. That is the total distance traveled. Okay, so just to recap, if you're finding distance traveled, it's kind of a lot of work. And that work involves, first of all, getting a picture of the graph, figuring out by factoring what the zero of that function is, because that 0, let me box it here, is gonna be where you are going to split your one integral into two integrals, so that the piece that's underneath the x-axis, the piece that's negative, you're still going to FTC and you know you're going to get a negative answer, but you're going to absolute value that answer. Okay, and that's the end of the notes. Thanks for paying attention. Have a good day.